Hey everybody, here's our first review, chapter 1. I'm going to do chapter 2 as well, and then there's one for you to practice on your own. But your first test will be covering chapter 1 and 2. Okay, so properties. Which of the following is not a physical property? Now remember, physical properties describe what something looks like. Chemical properties describe how something changes. So color is definitely physical. Temperature, physical. Phase or state, that means is it a solid, liquid, or gas? Again, you're just describing it. So it has to be flammability. Flammability means it burns. Well, when it burns, then it's going to become something different. Okay, which of the following is a chemical change for a substance? Again, when you have a chemical change, you can have a new substance. Well, if you drop in temperature, you're just cooling it off. You can dissolve, if you dissolve something that it's still there, okay? If you change the number of electrons, now it's going through a chemical reaction. So it's got to be that one. And breaking it up, again, if you take a big chunk and you smash it into smaller chunks, it's still the same substance. So it would have to be changing the number of electrons. Okay? A pure substance, okay, is a, remember, all matter is two things. It's either a pure substance or it's a mixture. Okay, if it's a pure substance, its composition is always the same. If it's a mixture, it can change. So we got a type of mixture, we know it's not that. Material which does not have a formula, well, a pure substance does. A material that has variable proportions, again, that's a mixture. So it has to be elements and compounds. Those are pure substances. Their composition never changes. So several pure substances, again, they're elements and compounds. So we got pure water, not tap water, but pure water. Salt, sugar, iron. Now I'm naming some, these are all elements. Iron, copper, nitrogen, oxygen. Okay, their composition is always the same. Baking soda is another example. Okay, so if their composition doesn't change, no matter where you get it from, then you know it's a pure substance. Okay, which of the following is a compound? Chlorine's an element. Salt dissolved in water, that's a mixture. NaCl, that's sodium chloride, that's salt, that is a compound. And any mixture is definitely not a compound, because a compound is a pure substance and a mixture is not a pure substance. Okay. An example of a homogeneous solution. Homogeneous solution means it's really well mixed, but it's a mixture, okay? So milk depends on the kind of milk. If you get skim milk, I don't even know if there's anything in there. But like whole milk, you got layers. Salad dressing, you get layers, little parts in there. Stirred salt water. In other words, you dissolved up the salt. This would be your homogeneous solution. Okay, it's a well-mixed mixture. And then concrete, of course, concrete, you can see little rocks. You can see different parts to it. So it'd have to be stirred salt water. Okay, another name for a homogeneous mixture is a solution. So when you're talking about all classification of stuff, all matter is either a pure substance or a mixture. A pure substance, the composition is always the same. If you can break it down into smaller parts, it's a compound. If you can't, it's an element. That's your two pure substances. Mixtures are just that, they're a mixture. If they're well mixed, if they, you can't see different parts to them, that's a solution. Okay, they're not so well mixed. If you can see layers or you can see stuff in them, that's a heterogeneous mixture. Okay, so that's the difference between all of matter and how you classify it. Shut up. Oh, dogs. Okay, significant figures. This one would only be 1. These are all placeholders, so just only 1. This one, 1, 2, 3, 4. You count them all because you wrote the decimal and you wrote the 0. If you took the time to do that, you must have measured up to that point, so count them all. This one, just the 11, 1, 1, just has 2. These zeros, because there's no decimal, they're like an estimation. How many were there? There was like 11,000. You didn't count, you didn't measure, so you just write 11,000 this way, and then you don't count the decimal. This one, we'd count these 3, and these 2. Again, why would you take the time to write the decimal and write 2 more zeros? You didn't change this number really in that sense, but you must have measured up to this point. Your instrument measured up to this point, and it just happened to fall on 0, so you'd count them all. And this one, you'd count them all as well because they're non-zeros, and then the 0 you write on the end. Any zeros you write after the decimal, they must be significant because, again, why would you write them? You're not changing this number in that sense, but you just telling me how many numbers I measured up to. Okay, and here's some, like those two, you'd add them together, and this is what your calculator says. Now remember, when you're adding and subtracting, this goes 2 past the decimal, this goes 1, so I have to round this answer, so it only goes 1 past the decimal, so it'd be 10.2. Okay, This one again, I'm going to subtract them. When I subtract them, I get this number. And that's just regular calculator stuff. So now I look, this goes 1 past the decimal and this goes 2. So I have to round, this only goes 1 past the decimal. So I'd make it 76.3. Okay. Here another one. Again, when you add them using your calculator or on a piece of paper or whatever you do. Okay, this goes 2 past the decimal, this goes 3. So my answer can only go 2, so I'd make it 2.39. Okay. Subtracting, same kind of deal. Subtract the numbers, and again, round this to 1 past the decimal. So 709.3. Add the numbers together, and then look, 1 past the decimal to round it to 1, so make it 0.6. All right. I guess I probably did a lot of these, but I think you get the idea. So when you're doing adding and subtracting, you have to worry about the decimal. Okay. When you're multiplying, it's a number of significant figures. So when you look here, this has 3 significant figures and this has 2 significant figures. You multiply them together, these two numbers, and you get 122.85. But because I have to round it to only 2 significant figures, I'm going to round it to 120. And don't write a decimal. This would only have 2 significant figures. Okay, same with this. Multiply the 2 numbers together. This has 3 significant figures. This only has 1. So, sorry about that. 1872, well, I can only have 1 significant figure, so I'm going to round it up to 2,000. And again, don't write a decimal. This only has 1 significant figure, and it's close to that number. Okay, and again, multiply them together, 0.064. I can only have 1 significant figure, 0.06. Okay, dividing is the same deal. 4 significant figures, 4 significant figures. Well, when I divide, I get this number. Can only have 4 significant figures, so 1451. Okay. And again, the reason why we do this is if you're going to take measurements and you're going to do calculations, you have to make sure your answer isn't more accurate than the measurement that you took. So that's why it's important to round when you do measurements, calculations with measurements. Here we have 69 divided by 7. Okay, so you divide that and you get this number. And I can only have 2 significant figures, so I round it to 9.9. 5 times 5, we know, yes, that's 25. But in significant figures, it's actually 30. Okay, again, you can only have 1 significant figure. And again, don't tell any math teacher I told you that, because they'll probably come and punch me. Okay, all right, density is mass divided by volume. Okay, so if I have the mass and I have the volume, now these are measurements, so when I'm done, I got to make sure I have my proper number of significant figures, right? So when I take mass divided volume, I get this number. Well, this has 3 significant figures and this is 2, so I round it to 2.0, and it's grams per milliliter, again, because I only have 2 significant figures. Okay, lung capacity, 1 gallon. So these are conversions. 1 gallon is 3.7854 liters. That's in your book, you guys. You don't have to know that. Okay, so I'm going to change 5 times 10 to the 3 liters times my gallons. See, what I'm trying to do is I'm getting rid of liters. I got liters on the bottom and I got gallons on top, because this is just like multiplying by 1. So when I'm converting 1.3 times 10 to the 3 gallons, that's the same as liters when I converted this. And again, all I did was use a conversion factor. 1 gallon equals this many liters. So liters, put it on the bottom, gallons on top. And in this case, I would just divide those 2 numbers and I'd get my answer. Okay. If I'm trying to convert a bumblebee speed into kilometers per hour, because a bumblebee, yeah, they move pretty fast, but it's not like, they move 15.2 meters per second. So this one I'd have to convert first the meters to kilometers. So again, I take my 15.2 times 1 kilometer and I divide by, in 1 kilometer, there's 1,000 meters. So meters cancel out. Then when I divide these numbers, that gives me how many kilometers they fly. And that's would be in a second. So now I have to change my seconds to hours. So 1 second, 1 second is, there's 60 seconds in a minute. There's 60 minutes in an hour. So I change seconds into hours. That's how much of an hour a second is. and then I just took what I found here, divided it by here, and I find out that bumblebees, they fly 54.7 kilometers in an hour. Okay. I don't know if they could fly that long because, you know, they need to take breaks and they need to suck on nectar flowers, but you get the idea. Okay. Okay. The Statue of Liberty is 151 feet tall. She's 150. How many meters? Well, and again, in your book, you'll have this. A meter is 1.0936 yards. So I have to change feet. Here I got feet on the bottom and yards on top, and then I got yards and meters. And so I just took 151. I multiplied everything on the top, which was just ones, and then I divided by 3, and then I divided by 1.0936, and I got 46 meters. So now you know the Statue of Liberty is 46 meters tall. Okay, so that's the first chapter. Again, you can go through those again. It's just to help you. I'll now do the second one for you in the same way. And if you have questions, just let me know. Email me, text me, or call me, whatever. Okay, so that's the end of this one.